Okay, so we're going to talk today about electromagnetic radiation, and electromagnetic radiation is energy traveling as electromagnetic waves. I'm sure that you have seen this before in physical science and in chemistry and other things. So you should feel fairly comfortable that you have seen this before, even when you go back to when you were in younger grades. You probably have seen some part of this before. But there are three primary characteristics of electromagnetic radiation, and that is wavelength, frequency, and amplitude. Wavelength is abbreviated lambda. That's how you see it in an equation, and that is the distance between two consecutive peaks or troughs. So if we're talking about a peak here and here, this is our wavelength, okay? If we're talking about troughs, here is our wavelength right here. It's measured in length, hence wavelength. That can be millimeters, that can be centimeters, that can be nanometers, which is something that you will see a lot. The frequency is abbreviated nu, and that is the number of waves or cycles. So, oops, CYCLES. Okay, so a cycle is, this is a whole cycle from midpoint to midpoint, or this is a cycle from here all the way through, okay? So it is going to be a cycle is to include an entire wave from the top part to the peak to the trough. That is going to be one cycle, okay? Now, that is measured in cycles per unit time. So 1/seconds, which also can be called seconds to the -1, which actually also could be called hertz, Hertz, or abbreviated Hz. And radio is measured in hertz. Radio waves are measured in hertz. The amplitude is the height of the wave. So this is going to be our amplitude from midpoint to the peak or midpoint to the trough. And it determines our intensity or our brightness of electromagnetic radiation. The one that I didn't do, the one that I didn't talk about was that speed. Speed is c, and all electromagnetic radiation travels at the speed of light. And that is 3.00 times 10 to the 8th meters per second. Okay? Now, what I'm going to show you, nope, not yet. Sorry, I got a little bit ahead of myself. Now, the next thing is that the relationship between wavelength and frequency is this equation right here. C, which remember we talked about C was the speed of light, equals lambda nu. Okay? Lambda times nu. So they are, because we're looking at this equation right here and we see that as one goes up, the other goes down because this is a constant, that means that they're inversely related. Oops. Okay? When wavelengths are longer, then less of them can fit through in 1 second, and therefore the frequency is lower. Okay? Now, the next question says, draw a wave on the wave above, which is on the previous slide, that has half the amplitude and twice the frequency. So go ahead and pause this and draw your wave that is half the amplitude and twice the frequency. Okay, so what you should have gotten was something like this. Sorry, I'm terrible with this. Okay, so you would fit an entire cycle or an entire cycle here from here to here. You're trying to get an entire cycle where you normally would get on this old wave half of a cycle. So that's half of a cycle for the red wave. And for the blue wave, it is a full cycle. That is going to double your frequency. You want your amplitude, your height, to be half of what it is there. I did an okay job. It gets a little wonky at the end, but you know what I'm talking about here. So the amplitude is half, and the frequency is double due to the fact that in half of a cycle here, we can fit an entire cycle here. Okay? All right. So you've heard of the electromagnetic spectrum. I'm sure you're going to hear the song as we go along, but the electromagnetic spectrum is this. And so we start over here with gamma rays and X-rays and ultraviolet. And again, you may be singing this song in your head. And then you'll notice that violet is the lowest of the visible range, and it goes up to red, which is the highest, and then it goes to infrared. The way that I remember this is ultraviolet is close to violet, infrared is close to red. Microwaves, radio waves, AM radio waves, FM radio waves, and AM radio waves. So what we can say here is this. On this side, we have very, very, very short wavelengths. So our wavelengths are very short, which means because they're inversely proportional, our frequency is very high. And you can see that you can fit a lot more in the same amount of space, right? And that makes our energy really high. So that's why these gamma rays are really damaging to your body. And then as we go along, you'll notice that the wavelength gets longer and longer, right? And so on this side, our wavelength is very long, but our frequency is very low, okay? And our energy is really low, okay? That's why when you're near your radio, that's not going to damage any skin tissue or anything like that. So hopefully that gives you a little bit of information here about electromagnetic radiation. And you can fill in your tables and ask questions as you have them.